Hello everyone. Today we will be solving a couple of AP problems related to distance time graphs, speed time graphs, and acceleration time graphs. For each of these problems, I would encourage you to pause the video and try to solve the problem by yourself before looking at my solution. So here we have the first problem, which is asking which of the following pairs of graphs shows the distance traveled versus time and the speed traveled versus time for an object uniformly accelerated from rest at time t equal to 0. And here we're given 5 options. So when reading this question, notice that our key term over here is uniformly accelerated from rest. That this means that our acceleration is constant, and that if you can draw an acceleration time graph for the situation, it'll look something like this. Now, if our acceleration is constant, that means our speed must be increasing in a linear rate, in a linear fashion. That means that we can eliminate options B, C, and D, as if you notice the speed time graphs over here are increasing exponentially. This leaves us down with options A and options E. Now let's take a look at the distance. We know that since our speed is constantly increasing, that means our distance, that the rate of change of our distance must be increasing as well. In option A, we can see that that rate of change is actually getting smaller, so that means that that cannot be the answer either, which gives our final answer as option E. In this problem, we are given the velocity time graph of two cars, car X and car Y, and we are given that car X, which is traveling at a velocity of v0, just passes car Y, which is starting to move. And we need to find out which of the following is true at time t is equal to 20 seconds. Now, if you look at all of the options, you'll see that options A, B, and C are all related to the distance, and options D and E are related to the acceleration. Let us look at the acceleration of the graphs first. We can see that the velocity of car X remains constant throughout the whole journey. It's always v0. That means that the acceleration of car X is equal to 0. We know that car Y speed is increasing. That means that it has some acceleration. So option D is both cars have the same acceleration, and that is obviously wrong because we know that car Y has some acceleration. Car X is accelerating faster than car Y is also wrong because car X's acceleration is 0 and car Y's acceleration is some positive number. Now let us look at the distance. Now recall that the distance traveled in a certain time is the area of the region under the graph between that interval. So looking at car X, we can see that the area of under car X is given by this area over here. And we can also see that the area traveled under car Y is given by this triangle over here. Clearly, the area under car X is more than the area under car Y, which shows that car X has traveled more distance than car Y. That means our final answer is that car Y is behind car X. Now the next question, we're given that from time t equal to 0 to time t equal to 40 seconds, that is over this whole interval, we can see that the area under both curves are equal. And they are asking us which is true at time t equal to 40. Now remember from our previous question that the distance traveled is the area under the curve. Since we know that the area under both of the curves are equal, that means that the distance traveled by both of the cars must be equal. That means our answer is car Y is passing car X. As we know that car y is accelerating, which means that it will overtake x some point after the starting. In this question, we are given the velocity time graph of 5 particles A, B, C, D, and E that all start from the origin. And then we need to solve 3 questions based on that. Our first question is, which particle is the farthest from the origin at t is equal to 2 seconds? Recall that this is related to distance, and we know that distance traveled in the velocity time graph is equal to the area under the graph. So all we need to do is compute the area for each of these particles. Let us start by the particle A. Notice that the area under this graph is this triangle, which has a base of 2 and a height of 1. That means the distance traveled by A is equal to 1/2 times 2 times 1. That is equal to 1 meter. Moving on to particle B, we see that this area is a rectangle with a width of 2 and a height of 0.5. That means the distance traveled is 2 into 0.5. That is also equal to 1 meter. Moving on to particle C, we see that this particle starts off with a positive velocity as it is going in the positive direction, but then it turns around and then goes with a constant velocity in the negative direction. This means that our particle, since the two areas are equal, this means that our particle just came back to where it started from, which means that the displacement or distance traveled from the origin is 0 meters. Now looking at particle D, we see that the area under this graph is given by this area over here. Notice that we cannot calculate that area directly, but we can notice that this area is always going to be less than the velocity, the area under particle A, as you can see that I have drawn the other side of the triangle in black, and we can see that clearly this area is smaller than the area of the triangle because the curve is always under this line. So here we can write this as this must be less than xv. Finally, we have x of e that is equal to this area over here. Notice that this is going with a negative velocity, which means that it is going in the opposite direction, that is away from the origin in the negative direction. We see that the area of this is equal to 2, which is the width of the rectangle, times 1, that is also 2. But notice that this is 2 meters away from the origin. However, the question is asking for which particle is the farthest from the origin, which means that our direction doesn't matter, which shows that our answer is option E, which is particle E. Our next question is asking us which particle moves with a constant non-zero acceleration. So the key word here is constant and non-zero. So let's start with particle A for this one again, and notice that its velocity is increasing linearly. That means that the acceleration is constant and it is not a zero, and it's non-zero. That gives our answer as option A. We can also check this for each of the other particles. We can notice that particle B's acceleration is 0. Particle C's acceleration is also 0. And particle E's acceleration is also 0. Particle D's acceleration is not constant as it's consistently changing, which shows that our answer is A. For our final question, we are given which particle is in its initial position at t is equal to 2 seconds. Again, let us look at our distances from the origin, which we have over here. We see that only one of these particles is exactly where it started from, and that is x of c. That shows that our answer is going to be option C. In this question, we need to find out which of the 5 graphs given could correctly represent the motion of an object moving with a constant speed in a straight line. Now notice here that our key term is constant speed, which means that the object should have 0 acceleration. Looking at our graphs, we see that 2 of these are acceleration time graphs, which are graph 3 and graph 5, and none of which have an acceleration of 0. That means both of these graphs cannot be the answers. Now, let us look at graph 4, which is our speed time graph. We can see that our speed is not changing, which means that in graph 4, the object is moving with a constant speed, which means that this is one of our correct graphs. The other graph which is speed time graph, is graph 2. We can see that our speed is increasing, which means that that graph is wrong. Finally, we can look at graph 1, which is a distance time graph. Remember that the speed is going to be the rate of change of the distance. Since we can see that our rate of change of distance is constant, that is, the slope of this line is constant, we can see that this answer does represent an object moving with a constant speed. From this, we can see that the 2 options that are correct are graph 1 and graph 4, which means that our answer is D. A quicker way to do this is to just look at graph 4 and notice that it is one of the correct answers. And then looking at the options, we can see that only option D has graph 4 in it, which means that it must be the answer. In this question, we are given the motion of a circus clown on a unicycle, and here we have the velocity time graph of the clown. Our first question is, what would be the acceleration of the clown at t is equal to 5 seconds? That acceleration in a velocity time graph is equal to the slope of the line. Here we want to find it at t is equal to 5 seconds, that is over here. Since we know that the slope of the line between 4 and 6 is the exact same, we'll just try to find the slope of this line over here. We know that slope is equal to rise over run. We can see here that our rise is 4 and that our run is 2. That means that our slope, which in this case is our acceleration, will be equal to 2 meters per second squared. That means that our answer is C. Our second question is, after 12 seconds, how far is the clown from her original starting point? Notice that here we are talking about the distance of the clown. And recall that the distance traveled in a velocity time graph is the area under the graph. So we need to find the area under this graph. Notice that we can split this into 2 trapezoids, as shown over here. Now, let us try to find the area of this bottom trapezoid, shaded in pink. The formula for the area of the trapezoid is equal to 1/2 times the sum of the 2 parallel sides times the height. Here, our first parallel side is 12, and our second parallel side is about 10 minus 2, that is about 8. So we'll just let our area, be approximately equal to 1/2 times 8 plus 12, that is 20, times our height, that is 6. We can see that this will be equal to 60 meters. Since looking at our options, we see that there's only one option that is above 60 meters, and that is option D. That means that this must be our answer. If you want, you can always go and find the exact area by dividing this up into triangles and rectangles. In this problem, we are given a velocity time graph for an object that is moving in linear motion, and we need to find a possible position time graph for the object. Now let us begin by trying to describe what the object is doing if it has a velocity time graph that looks like this. So we can see that the object starts with a constant velocity and it stays constant for some time. We know that if the object's velocity is constant, that means that the displacement must be increasing at a linear rate. Looking at our options, we see that B, C, and D are not increasing at a linear rate, so and all of them must be wrong. After some time though, the velocity of the object starts to decrease before it reaches zero at some point. When it reaches zero, that is here, notice that our displacement, that is the area under the graph, is still positive. In looking at option E, we see that our displacement is zero, which cannot be the case, so that must be the wrong answer. We see that we are left with option A, which is going to be the correct answer. Here we have another problem which is similar to the previous problem. We are given a velocity time graph of an object and we need to find the correct displacement time graph. So let us start by analyzing the object. So let us say that the time over here is t1 and the time here is t2 and the time here is t3. So from time equal to 0 to t1, we can see that the velocity of the object is increasing at a constant rate. That signifies a uniform acceleration which is occurring on the body. From t1 to t2, we see that the velocity is constant, which means the acceleration is 0. And from t2 to t3, we see that the object decelerates back to a velocity of 0. Now let us look at the displacement time graphs. So we know that from 0 to t1, our object is undergoing a constant acceleration, and that acceleration is positive. Since the acceleration is positive, the displacement time graph will behave like a quadratic because the formula for displacement, if the initial velocity is 0, is going to be s, or x actually, is equal to 1/2 at squared. Looking at our options, we see that only options B and D behave like a quadratic, which means that these options are incorrect. Now let's look at the second part of the journey between t1 and t2. During this time, the velocity is constant, but our displacement must still be increasing at a linear rate. Looking at our options, we see only option D has that, so that means that our answer is option D. In this problem, we are given the acceleration time graph of a car, and we are asked two questions. The first of which is, at what time would the car be moving with the greatest velocity? Now, in an acceleration time graph, recall that the area under an acceleration time graph will always represent the velocity, and we need to find when that area is the biggest. Looking at the graph, we can see that when t is equal to 4 seconds, we see that our acceleration has come back to 0, and we see that we have this triangle, the area of this triangle, as our velocity. If we go beyond that, we see that we're gonna have some negative area, which means that some amount will be subtracted from the area of original triangle. That shows that at t equal to 4 seconds, our area is the greatest, which means that the answer is 4 seconds. Another way to think about this is recall that the velocity will be the greatest as long as the acceleration is positive. Once the acceleration reaches 0 and starts going to negative, the velocity will start to reduce. That means that our greatest velocity will be at t equal to 4 seconds. For the second question, we have to find out the time when the car is the farthest from its original starting position. Now notice that the car will continue to move away from its starting position as long as the velocity is positive. The moment it hits 0 and just starts to go into negative, the car will start to go towards the starting position. That means that the maximum displacement is when the velocity is 0. Now looking at our acceleration time graph, velocity is the area under the graph, and we can see that if we add up the area of this triangle and this triangle, which has negative area, we will get 0. That means that at t is equal to 8 seconds, our velocity becomes 0, which means that the car is farthest from the original starting position at 8 seconds.